Welcome to Khetz Tutorials, and in this video, I'll be doing question 37 from 1.3 exercises in James Stewart Calculus. So, we asked to find each of these functions. Starting with A, we're going to find f of g. So we're going to substitute g wherever we see an x in f. So x plus 1 over x plus 2, then plus 1 over, so there's an x below, so we're going to substitute g there. And this is what we have. This here allows us to just add this with its reciprocal. So if you divide here, 1 divided by this is the same as 1 multiplied by the reciprocal. The reciprocal is x plus 2 over x plus 1. Then we can now find the common denominator, which would be x plus 2, x plus 1. And at the top, you just have x plus 1 squared plus x plus 2 squared. So this is what you get after multiplying. Dividing x into the x plus 2 into this gives you x plus 1. X plus 1 multiplied by the x plus 1 gives you x plus 1 squared, and the same applies to this one. Okay, so this is where we are. You can either continue multiplying through to see what you have, or you can use this to find the domain. So we're going to find the domain of g first, which is what we substituted into this, and its domain would be anything as long as this denominator there is not 0. So x plus 2 not equal to 0, or x not equal to minus 2. So that is the domain of the g that we substituted. Then the domain of f of g, we're looking for the intersection of the domain of f of g as well as the domain of g. The domain of f of g, as you can look here, we also don't want this to be 0. So this can be anything as long as x is not minus 2 and x is not minus 1. So any other x value can be substituted in here to produce a valid function, as long as they are not these ones. And as you can see, there's an overlap there, and then there's this extra one. So you can give the domain of the overall function as this, because it covers everything. X can be anything as long as x is not minus 2 or minus 1. Alright, moving on to B. In B, we are asked to find g of f. So we're asked to find g of f. So we're going to substitute f into g. So wherever we see an x in g, we're going to substitute f. So we have an x at the top, then plus 1. And then the bottom, we also have another x. We're going to substitute the whole of f plus 2. We can deal with the top and the bottom separately. At the top, we can use a denominator of x. Then we're going to have x squared plus 1. There's x. At the bottom, we can do the same. Have a denominator of x. Then it will lead to x squared plus 1 plus 2x. At this point, we can just multiply the top part by the reciprocal of the bottom part. So we're going to have x squared plus 1 plus x over that x multiplied by x over x squared plus 1 plus 2x. Alright, so the x's cancel, and we're now just left with x squared plus x plus 1, x squared plus 2x plus 1. And we can now find the domain. So as you can see, x can be anything as long as the bottom part is not 0. And the bottom part is essentially just x plus 1 squared. As you can see, if you do the math on this, it gives you x squared 2x plus 1. So that's the bottom part. We should just make sure that that is not 0. So we should make sure the x is not minus 1. We're also going to check the domain of f, which is substituted into this to see what it is. The domain of f is, so we're just going to make sure that x is everything as long as x is not 0. If you look at f, the only thing that will lead to division by 0 is if x is 0. So we don't want that. So that's the domain of f. And the domain of the combined function g of f is dependent on this. So we don't want this part to be 0 because we don't want division by 0, or we don't want undefined behavior. And that bottom part is x plus 1 squared. So x can be anything as long as x is not minus 1. So to finalize what the domain would be in this case, we're just going to make sure that we have an x that can be anything as long as that x is not equal to -1 or 0. So the final domain of the whole function would be x can be anything as long as x is not equal to -1 or x is not equal to 0. So that will ensure that this function exists. Okay, then now we can go to the next one. And in the next one, we're going to have C. So C is f of f. So you're just going to substitute f into itself. So there's an x here. So you're going to substitute f in the first place. Then there's an x underneath. So we're going to also substitute f again. And if you work this out, then let's see how we can work this out. So this is what we have. We have an x plus 1 over x over there. And we have a 1 divided by f again. And at this point, what we can do is we can focus on the bottom part here. You can still leave this as it is. Then down here, we can deal with this with the denominator of x. So we're going to have x squared plus 1. Then we can reciprocate this. So we have x plus 1 over x. Then the reciprocal of this because of division. And this is where we are right now. So at this point, we can now find the common denominator of everything, which would be x squared plus 1. And with the first one, that would give us x multiplied by x, then multiplied by x squared plus 1. With the second case, this part, it'll give us x squared plus 1. And with the final one, we'll just have x squared, so x multiplied by x, because it already has this part of the common denominator. Then you can either decide to continue, multiply through and work on this. You can see that the top part shouldn't give us any trouble, but the bottom part might. So we just have to make sure that this here is not 0, because if that is 0, then it'll give us a denominator of 0. But on this side, this can be anything, because that part will never be 0, because this will never be negative. The x squared part will never be negative, so it has no potential for making this 0. So we only worry about this one. So the domain of f is, so the one that we substituted in, is x can be anything as long as x is not 0, because this is f. We just want that denominator to be valid, so that doesn't give us undefined behavior or division by 0. And with the resultant function f of f, we just want the same thing. We don't want that to be 0, because that will give us division by 0. This can never be 0, but this can, and that happens if it is 0, or if x is 0. So x can also be anything with this one, as long as x is not 0. If you look at the two domains, they're exactly the same. So that should tell you that the domain of the overall function will be this. X can be anything as long as x is not 0. Moving along to the final one. In the final one, we now asked to find g of g. So we're going to substitute g in itself. So wherever we see an x in g, we're going to substitute g again. So x plus 1 over x plus 2 plus 1. And the bottom again, x plus 1 over x plus 2 and then plus 2. Okay, so I can deal with the top and the bottom separately, then work with that when we're done. So we have x plus 2 at the top, we're going to have x plus 1, then x plus 2. And at the bottom, we're going to have a similar thing. We're going to have x plus 2, then we're going to have x plus 1 plus 2x plus 4. Okay, at this stage, we can now add the stuff at the top. So it'll give us 2x plus 3 over x plus 2. And at the bottom, we will have 3x plus 5 over x plus 2. Okay, now we can multiply using the reciprocal. So the reciprocal of the bottom part, that will give us 2x plus 3 over 3x plus 5. Okay, so now we're ready to find the domains. The domain of G will be all x values as long as this, which is G, doesn't have a denominator of 0. That's if x is not equal to minus 2. Then the domain of G will be dependent on this. We don't want that to be 0. So we just have that, and it should not be 0. So it'll be the following. X should not be negative 5 over 3. That is the condition that we're going to have. So to combine these, we can say x can be anything as long as x is not negative 2 or x is not minus 5 over 3. That'll be the domain of the overall function.